Hello there, Mr. Sutton here with the Pre-Cal Honors 4-2 Extra Practice Solutions on Compound Interest. For this problem, we have Jasmine investing $8,935 in an account with a 5.45% three-time compounded interest rate. We want her balance after 6 years. So since we're compounding multiple times a year, we are going to use PB to the T, but we're going to have to change the B value a little bit here. So that's going to be 1 plus, and now we need the interest rate over the number of times we're compounding. So this is going to be, let's see here, move the decimal 0.0545 up here, and we're dividing that by 3 because we're compounding 3 times a year, and we're raising all that to the third power. So let me do this on the calculator. So here we go. I've entered all this in my calculator, and one other thing I'm going to do while I'm at it is I'm going to store this value as one of the letters here. I'll just do alpha B, and now whenever I call up B, I get the exact value of this thing. Now on the paper, I'm just going to round it off to 1.0555, but I'm actually going to use the true non-rounded value in my calculator. Okay, so plugging everything in, we're doing f of 6 because we want this account balance after 6 years. Our principal, that was the $8,935 we started with. And then for the B value, we've got this value we just found here. And again, I'm using the true value on the calculator, raised to the power of 6, because 6 years. Let's see what that comes out to. So you'll notice when I actually plug this in the calculator, I'm doing 8,935 times B, because that's where I stored this value, raised to the power of 6. And that's going to come out to about $12,354.76. For this problem, we've got some money invested in an account with quarterly compounding. So let's figure out what this account balance is going to be after 12 years. So I'm going to use PB to the T, and I'm going to change my B value to reflect this quarterly compounding. So to get the B value, I need to do 1 plus, and now I'll have my interest rate, so 0.0269, divided by the number of compounding periods. It's quarterly, so that means we're doing this 4 times a year and raising this whole thing to the power of 4. Let me store this value on my calculator now. So in addition to entering this in the calculator, you'll notice I'm also storing this value as B on my calculator, and this is about 1.0272, but again, I'm going to use the true value on the calculator. So now plugging all this in, we've got my principal of 3,734 going in for P, and this is going to be the B value we just found, raised to the power of, the time is going to be 12 here. So let's do that on the calculator. So plugging all that in with my B value here, so I can use that whole interest rate, or my whole B value rather. That's going to be about $5,151.04. On this problem, Sarah Wong invests $5,190 in an account with 5.74% compounded every other month. We want the balance after 15 years. So since we're doing this more than once a year, we need our compounding formula. We're going to start with PB to the T, but then our B value needs a little bit of an upgrade. So that's going to be 1 plus, and now my interest rate, 0.0574 up here. And we're dividing by, well, let's see, every other month. So that means 6 times a year, raising all of this to the power of 6. And now let's put this on the calculator. So I'm entering all this in the calculator using my fancy fraction and some exponents. And notice I'm storing this using the stow button as a value B, or whatever letter you want. So that comes out to about 1.0588. I mean, that's what I'll write on the paper, but I'm really going to be using the whole value here stored as B. So there's the paper version. So now plugging all that into PB to the T, we've got f of 15, because 15 years. There we go, f of 15. That's going to equal principal of 5,190 times this B value that we just wrote here, raised to the, not the 6th power, the 15th power. That's the time here. And now let's use the calculator again. So plugging that in the calculator, using my stored value of B for this 1.0 business, that's all going to come out to about $12,226.94 if I round off there. On this problem, Scott is investing some money in a savings account compounded at 6.61% continuously. We want his balance after 9 years. Continuous compounding, that's a big tip off here. That immediately tells us we are using f of t equals PERT, P-E to the RT. So this is going to be f of 9 because we're plugging in 9 for the input for the years. Principal is going to be $5,605 times e to the, for r we have to use the decimal version of this, so 0.0661, and we're multiplying that by a time of 9. Let's plug all that in the calculator. So plugging all that in, doing second ln to get my e to a power here, this all comes out to $10,161.02. For this problem, Callie invests some money in a continuously compounded savings account, 3.52% interest. We want her balance after 14 years. So for this, we're going to use our PERT formula because it's continuous compounding. So I've got f of 14, not 4, equals our principal of 1,700 times e to the interest rate of, now we have to move the decimal here, 0.0352 times our time that they wanted of 14. Plugging all that in now. So there's what it looks like on the calculator. Press enter on all that. We've got $2,782.72. For this problem, we have Kim investing some money in a savings account with an interest rate of 4.25%, compounded monthly. What is her balance after 7 years? We'll start with a PB to the T formula here, but my B value is going to need an upgrade. So I'm going to have 1 plus R over K to the K. So 1 plus the interest rate, 0.0425, divided by, well, let's see, compounding monthly. So that's a K value of 12, because 12 times a year, all raised to the power of 12. Now let me figure this out on the calculator. So plugging all that in, I am also going to store that as a B so that I can call it up anytime I need to, and I'm going to need to pretty soon. So that comes out to 1.0433 if I round it off, but I'm not going to round it off when I actually plug it in on my calculator. All right, let's write out what I'm plugging in my calculator more or less. I've got f of 7, which is going to be my principal of 2,243, times the B value that we just came up with here, and then we're raising that to the power of 7 years. Let's plug this in. So here's what it looks like on the calculator, and I'm using this whole value stored as the constant B. Press enter here. That's $3,018.59. On this problem, we've got a Basra investing some money in a savings account with 7.25% interest. That's really nice. Compounded continuously, even nicer. We want the account balance after 12 years. Continuous compounding, we use the PERT formula here. So we're doing f of 12 for the input, and that's going to be our principal of $6,489 times e to the, let's see, interest rate. That's going to be 0.0725 if I move that decimal. And I've got a time of 12 that I'm multiplying by in the exponent. Let's plug it all in. So there it is on the calculator, and that's going to come out to about $15,488.66. On this problem, Mikhail is investing some money in an account with 4.25% interest, compounded 3 times a year. Balance after 20 years is what? So since we're not doing continuous compounding, we will use PB to the T for our formula. And for my B value, that's 1 plus R over K to the K. So in this case, that's 1 plus, let's see, R value is 0.0425. K value is the number of times I'm compounding over the course of the year. That's 3 that I'm putting down there. And the exponent is also 3. It's the same thing. It's the same K value. All right, on the calculator, I'm going to go ahead and enter all of that in the calculator. And I'm going to store that as B on there, or whatever letter you want, just so that I can reuse it again. So that comes out to about 1.0431. And there's some more decimals. I'm just going to write out the first 4 on paper, but I'll actually use the whole thing when I go back to the calculator. So what am I plugging in the calculator? I can say f of 20 equals my principal of 7,263 times the b value that I just found here, all raised to the power of 20. Let's see what that looks like now. So since I've already stored this value as b, I can just do 7,263 times b to the 20, and that's going to come out to $16,891.80. On this problem, Jenny's investing some money in a compounded monthly account, interest rate of 5.01%. We want her money after 11 years. So for this, I'll use PB to the T because it's not continuous compounding. And for the B value, we've got 1 plus R over K to the K. So that's going to be 1 plus the interest rate of, as a decimal, 0.0501, all divided by, let's see here, compounding monthly, so that's 12, and also the 12th power. On the calculator, let's see what that looks like. So plugging all this in and storing this as B so that I can pull it back whenever I want, I end up with about 1.0513 if I round it off. On the calculator, I'm not going to round off. I'm going to use the true value, but this is just kind of for show and tell on the paper here. All right, plugging it in, I've got my principal, so I've got f of 11 here, equals my principal of 6,138 times the b value here, raised to the power of 11, because I'm doing this for 11 years. There's what I've got on my calculator, using that stored value of b for my b value down here. And let's see, that's going to equal $10,638.20. And that's it for that one. For this problem, we have Jenny, who I think was on another problem too. Jenny's back apparently, investing some more money in an account with 6.14% interest, compounded continuously. Good for Jenny. So what does this come out to after 12 years? Continuous compounding, we're going to use PERT. So we have f of 12 we're calculating. This is going to be my principal of $3,082 times e to the interest rate 0.0614. We have to use a decimal there. And then we're multiplying by 12, because 12 years, that's the t value. On the calculator now, plug in all that in, we're going to get a value of about $6,439.04.